You're watching the Mr. Quality Guy YouTube channel.
Hello everyone, Mr. Quality Guy here, and today we're going to do a video on GD&T symbols and their meanings behind the symbols and how they can help you in quality. So sit back, relax, and let's get to it. When we talk about GD&T symbols and their meanings, it's important to understand what are some of the common symbols. And understanding symbols is quite useful. So we're going to look at the most common symbols. So the most common GD&T symbols are in this chart right here. They can be broken down into flatness, straightness, cylindricity, circularity, / roundness, perpendicularity, parallelism, angularity, position, profile of a surface, profile of a line, total runout, circular runout, concentricity, and symmetry. But we can see that these are all each broken down into different tolerance types. For example, flatness, straightness, cylindricity, and roundness is broken down into form with no relation between features. That, when it says no relation between features, that means there's no datum that needs to be, there's no datum reference in there. And it controls form, shape of surfaces, and also controls form of an axis or a median plane. Datum reference is not allowed, so these will not be related to a datum. However, when you jump down into orientation with no relation between features, an orientation does require a datum reference. So, for example, perpendicularity, parallelism, or angularity, one of the portions of it has to be a main datum. Controls orientation, tilt of surfaces, axis, or median planes for size and non-size features. Datum references are required. So example, you will always see a perpendicularity from one surface to a datum A or B or C, etc. And the same for parallelism and angularity. Now, when it comes to position, profile of a surface, and profile of a line, these are also locations. But only position will locate the center point axis and median planes for a size feature. Also controls orientation, while profile of surface, profile line will locate the surface, also control size, form, and orientation of surfaces based on datum references. When it comes to runout, you'll have total runout and circular runout. This will control surface coaxiality and also control form and orientation of surfaces. And finally, we get to location-derived median points with concentricity and symmetry. These will locate derived median points of a feature. These are not common. Consider using position, runout, or profile. Now, symbols concerning size are a little bit different. When it comes to symbols concerning size, this will be mainly your length, your diameters, and stuff like that. But these are where a lot of your modifiers come in. For example, you have least material condition and max material condition. With least material condition, your true position grows larger as the size of your hole gets smaller. And max material condition is the inverse. As your hole grows larger, your tolerance for true position also grows larger. You also have a tangent plane, a projected tolerance zone, and a free state. A free state is only used mainly in fixture-based. That means that the part is being measured unbound by the fixture. Diameter is simply the diameter of a hole. Radius is the radius of a surface, and that is half the diameter. Then you'll run into spherical radius and spherical diameter, controlled radius, statistical tolerance, which will be not super used very often. Basic dimension is just, hey, this should be approximately this, and a reference dimension is just that, a reference. When you go into places, that can be used in, hey, this radius is this much at this many places, and so that way you don't have to keep repeating. Then you'll run into a dimension origin, and then it'll tell you, hey, this hole needs to be counterbore, it needs to be countersunk, the depth of said hole, all around, which means every surface, between, which is your boundaries, target point, a conical taper, a slope, and a square. Some of these are used very often, some of these are not, but then we'll go into a typical GD&T bracket. So, your geometric tolerance symbol, then you'll go into your diameter symbol, your tolerance value, if it has a modifier, whether it be MMC or LMC, a projected tolerance symbol, which isn't generally used, your projected feature length, which also you will see very common, and then your primary, secondary, and tertiary datums. You can only ever use 3 datums, being a primary, secondary, tertiary. However, you can create a 3D line, so you're technically using 4. For example, if we go datum A, B-C to D, that means there is a 3D line between B and C, and that is your secondary in that case. Now let's head over to surface finish. So surface finish is the actual finish of the part, and generally you would be measuring these with a surfometer. But you need to know what the surfometer needs to be set to and all that, and you'll generally see a triangle pattern as seen above. But if we look at the picture below, then we know that, hey, the surface needs to be an RA of 1.5. That's telling us that we need to use the RA scale, and we needs to be at 1.5 or below. So GD&T is pretty difficult to master, but understanding what these symbols mean goes a long way in understanding what the designer intended. So that's on that.
Thank you for watching this video on GD&T Symbols. I hope you enjoyed it. Thank you, and you have a great day.